What is a port? Today we will find out how they work. Let's start by looking at some key things first. Ports are primarily used for network communication, but they can also help programs on the same computer talk to each other. Programs need port numbers to send and receive data, both locally and over a network. So in other words, ports act like doors for programs. They make sure data goes to the right program, whether on your PC or over the internet. A port number is a virtual number, similar to an IP address. It's a number, not a physical device, and it simply indicates where data should be sent. An important thing to know is that port numbers only exist in the range from 0 to 65,535. Port 80 is associated with HTTP, which means Hypertext Transfer Protocol, and we can see HTTP at the start of web addresses. HTTP is often used for websites, and it's insecure because data isn't encrypted. Port 443 is associated with HTTPS. The difference from HTTP is that the S stands for secure, so it's called Hypertext Transfer Protocol Secure. You can also see it at the start of web addresses. The main difference is that data is encrypted, which means HTTP is insecure. HTTPS is secure. SMTP is associated with port number 25 and is used for email services. Now we're going to look at how ports actually work, with some context. First, it's important to know what an IP is. An IP address is like your computer's address on the internet. It tells other devices where to send data. These are just example IP addresses. Ports and IP addresses work together to reach specific services or programs. Ports 80, 443, and 25 are always connected with IP addresses. Let's look at an example now. This is Paul. He wants to visit a website. To do that, he first needs the IP address of the server hosting it. The IP address tells the geographical location of that server. Let's use this IP and port number as an example. When the data reaches the server asks what we want. Because servers often have different services to offer, that's where port numbers come in handy. They tell the server which door we want to use. In our example, we just want to visit a simple website. That means we want HTTP. And as we can see, that's port 80. Okay, let's sum that up real quick. Ports and IP addresses work together. In our example, we have the IP 93.184.216.34 and port 80, which are usually combined with a colon. The IP address tells us where something is on the internet, geographically. The server has an IP address, but so does our own computer. In our example, our PC and the server are located in different places around the world. And lastly, a port number tells a device, like a server, which service the user wants to use. In our example, the IP address tells us where the server is located, its place on Earth. The port number tells us which service should be used. Port 80 is connected to this IP address, so we know the user wants HTTP. If you still haven't fully understood the concept, let's simplify it. Imagine a house. This house represents a server. The address of the house, let's say 1234 Elm Street, is like the IP address. It tells us where the house is located. Now, a house has doors, and behind each door there's something different. That's where ports come in. They tell us which door we want to open. In our example, that could be SMTP, HTTPS, or HTTP. In other words, door 25, 443, or 80. And since port 80 stands for HTTP, that's the one we're using here. Hopefully, now the principle makes sense. Now let's look at how ports are categorized. Ports are managed by IANA. That stands for Internet Assigned Numbers Authority. They're responsible for coordinating and maintaining the global system of IP addresses, domain names, and port numbers to make sure everything on the internet stays organized and works together smoothly. The first category are the well-known ports. These ports are used by the most common and essential internet services, the ones we interact with almost every day. Examples of these are HTTP, HTTPS, SMTP, and SSH. SSH, or Secure Shell, is a protocol that allows remote access to another computer. Next are the registered ports. They can be officially registered by developers or companies to assign specific applications or services uniquely. Examples include Port 1433, Microsoft SQL Server. It's a database application used to store large amounts of data like user info, website data, or other application data. Port 3389, RDP. It stands for Remote Desktop Control and is used for Windows Remote Access, allowing you to control a computer from another PC. Basically, the Windows counterpart to SSH, which is commonly used for Linux desktops. And last but not least, we have the private or dynamic ports. These aren't meant for servers. They're used on your own computer to make sure data goes to the right place. We'll explain exactly how that works in a moment. One basic thing to understand is that well-known and registered ports refer to servers, so that clients like you and me can access services, for example, to watch YouTube. Private ports belong to end devices like PCs. Let's imagine we want to watch multiple videos on YouTube at the same time. These videos are all different, so multiple streams of data are flowing at the same time. When our PC asks the YouTube server for these videos, the data comes back. But now the PC needs a way to organize it, and this is where private ports come into play. Whenever the PC establishes a new connection to the internet, whether it's YouTube or an online game, the operating system automatically assigns a new port number. This ensures that the returning data is sent back to the correct port on your computer, the one that requested it in the first place. Okay, so we want to watch a YouTube video. The operating system picks a free port number for that. Let's say port 50,000. If we now open a second tab with a different video, the operating system assigns a different free port number. For example, 55,000. In other words, the PC combines its local IP address with the assigned port number. The whole thing is then sent to a YouTube server to its IP address using port 443, the standard port for HTTPS traffic. The server sees which IP address and port number the request came from. That's why it sends the incoming data straight back to our IP and port 50,000. The data arrives there and the operating system instantly knows it belongs to that specific video tab. The last thing we need to understand before we get some context is the different states a port can be in. So let's take a look at the port states. Listening. When a port is in the listening state, it's waiting for incoming connections. This usually happens on servers, but it can also happen on our own devices. For example, when an app or local service is waiting for connections. It's important to know there's both incoming and outgoing traffic. Servers mainly receive incoming traffic, while we create outgoing traffic when visiting websites. An example is port 80. A server waits for clients to connect to a website, so port 80 is listening. Established or connected means there's an active connection and data is being exchanged between two devices. For example, when we're currently visiting a website, closed means the port is currently not in use. There's no active connection and no program is listening on it. That's why you usually don't see closed ports directly in CMD. You can think of closed simply as the port is shut down, not active. There are also other states like time wait or close wait, but those aren't important for beginners. Now that you know the most important port states, we can take a live look in CMD to see which ports are listening or established and observe how that looks in practice. To open CMD, go to your search bar. On Windows 10, it's located in the bottom left corner, and type CMD. Then press Enter, and the command prompt will open. Type the command netstat-n and press Enter. You'll see a lot of text with numbers and IP addresses. Don't let that confuse you, we'll go through it step by step. On the left, you can see the proto column. That means protocol. You'll mostly see TCP, which stands for Transmission Control Protocol. But for this video, that's not really important. We'll focus on the other columns instead. Next, you can see the local address column. That's your own address, basically your device. The foreign address column shows who you're connected to, a server for example. And on the right, the state column shows the connection status. If it says established, that means an active connection is currently open, as we already learned in the theory part. All these IP addresses and ports you see here are part of the loopback communication, basically internal traffic on our own computer. We won't go into detail here since that would go beyond the scope of this video. Here you can see our local address, the IP of our PC. along with our dynamic port number. On the other side is the server address we're connected to, along with port 443. I've blurred the server IPs for security reasons. To give you an example, I'm displaying fake IPs here, connected via port 443, so in this example, our PC is connected to secure HTTPS web pages. Type netstat-an and press enter. This now shows not only established connections, but also listening ones. All of this might look a bit complex at first, so we'll just take a small example here. Here we can see our local IP address with port 139. This port is often used for file and printer sharing within the local network. As we can see, the state says listening, which means this port is waiting for incoming connections. In the foreign address column, we have 0.0.0.0:0. Those 4 zeros are just placeholders, showing that there's no active connection, and the :0 means there's no remote port connected either. In this case, our PC acts as a server.